Hi everyone, thanks for joining on Zoom and on YouTube. This is part two of our blockchain workshop, and today's session is focused more on implementation. Uh, Theo is gonna show us a smart contract and its implementation in integration with Blender and Dynamo. So I'm quite excited for this. If you have any questions, definitely feel free to share it on the chat or on YouTube.
Perfect. Thank you for that. Thank you for the introduction. I mean, we've already done the introductory section, so I'll try and go immediately into discussing what we're going to see today. So this is closer to your heart, Mayur, because I'm going to show the script, the upgraded version of the script that we had in the topological token kind of idea. So this is still code we're still working on, but it's getting closer to release. I'm going to try and share my screen. Give me a second. You should be able to see remix and a code, right? So I'll explain, and I will also zoom in. For older people like me, it's better if you can, you don't need to zoom in on the video, right? So you can take a look at what everything is happening. So the components we use essentially in connecting BIM software or 3D modeling software with smart contracts are essentially, first of all, the smart contract. So you need to have set up the smart contract in a particular way that allows you to speak to it. So not all functions in the smart contract are public. So that's the first take. The second take is you need a connector. And the connectors you have available at the moment are web3.js or ether3.js. And these are both JavaScript libraries that require that you run a web server, a web page, and all of the related infrastructure, which for a design application, probably you don't want to do, right? So you don't want to both run a web server just to be able to speak to a smart contract. So the solution to that is to use a third library, which is web3.py, right? And you can find this on this documentation. So if you search for read the docs, web3.py, read the docs.io, you will get essentially web3.py. Now, the trouble comes from needing to set up your Python environment in a particular way that will allow, in the particular instance of what we're going to show today, Dynamo and Blender to be able to use your installation of web3.py to talk to the smart contract. So I'm going to show today essentially how to, let me try and show my screen. So we're going to use Dynamo Sandbox with a Python script embedded into it. And also Blender, the latest version, Blender 2.93, which we will also run with its embedded Python, but also connected to the Anaconda installation we're going to do. So okay, were you able to see my desktop? Because it came up that my screen sharing was paused.
I'm still seeing your Web3 device.
All right, okay, but now you can see Dynamo probably. Yeah,
No.
okay.
Not yet.
Oh, really? Okay. What is going on? Give me a second.
Maybe you have shared the
I shared only
window.
the browser. Yeah, sorry
Yeah.
about that. Give me a second. Yeah, I need to share full screen. Now we should be ready. Yeah,
yep.
Perfect. So since you already did the video with the hosting with Vasim, this is actually the newest version of Topologic Python running on Blender. That's why it takes a little bit of time. And I have to say, Topologic is one of the crucial components that we use essentially in the concept I will explain. So it will take a little bit of time to launch.
So we will get to see some latest work.
Yes, yes. So, well, it won't be impressive, but it will be, I will explain what the latest part is in terms of that. Let me set it up so I'm ready. So we have this, and then I can have also, I will need a Python console. Okay. And let's get back to the smart contracts. I'll explain that first. I will interact with it first, and then we will explain how exactly it works. So as I discussed in the other time, we can have essentially, when you write Solidity code, right, with 2 forward slashes, you essentially create comments, right? And if you need to explain to Remix which Solidity compiler you need to use, you write as such, right? So Pragma Solidity 0.7 and upwards. This is what means upwards. But you can also describe it in many other ways and only specify a particular compiler if you remove the upwards. However, I will leave it because it's good practice for you to test your code with modern compilers. Then, and one other thing I'm doing when I'm working with test code is I have a test account. So I'm not using my real account because one of the things I will probably do is I will showcase my personal key, which as I described, that's very bad practice. Don't do that, right? Always have a test account and use that with online development because it safeguards you. So sometimes with a contract, I will basically write a comment on saying, well, deployed on the ROPS10 test network with ArcChain1, this is the name of the account. And then what follows is essentially the address I will deploy the contract to, or I have deployed the contract to. And then I have a note addressing to the developer, not the user, right? So what does the contract do? It sets up an Open Zeppelin libraries, the next part, right? So these are all Open Zeppelin libraries that provide to me template functionality for what I want to do with an NFT. I will go through the contract first, and then I will explain to you, I will go and take a look at the Open Zeppelin library a little bit more carefully. And this is for using it with Remix, which is an online, the online version of Remix as a integrated development environment. So you will see that one of the differences compared to the addresses below here is that I reference their full online address on GitHub, whereas here I'm using them locally. So you will need to use, once we go through this, I'll show how to use it locally with, say, Truffle. So how to install them on your node environment. Give me a second to check something and make a note. Okay. So it's good practice if you're testing between using Truffle or any other kind of local environment like Brownie or Hardhat, right, to have both cases like this. And then starts the main contract. So when you're declaring this, you will see the contracts I'm using are the ERC 721, which is the non-fungible tokens contract. The ERC 721 burnable, this is an interface contract that allows me to burn the NFT. And then I import another template that allows me to pause the contract. And this is good practice so that you are able, as a deploying account, to pause the contract. If something happens and you need to upgrade it, you have the possibility that you pause it and you stop any other kind of activity. So if you discover that you have a bug in your code or a security hole, then being pausable allows you to stop any operations on its tracks. Counters as a library allows you to use essentially a template that prevents reverting for integers. So if you have a uint 8 and you arrive at its end and you increase it by 1, normally Solidity will revert. So it will go back to 0, right? And you don't want to do that. You need to be able to operate within the boundaries of your integers. And then access control allows you to create more than one role for the contract, right? So you might have one person who is minting the NFT, but also you might have a couple of others. You will see how I have a poser role as a separate role. And these are separate to the account creating the contract. So you can deploy the contract as the owner, but you can send also a minter role for your colleagues to be able to mint a new NFT.
So how do you change the permission? Like right now, you might have all the control of the network, and then you might provide limited control for people to mint, right?
Yes, exactly. So what I will do is essentially, I'll show you how the code sets up the roles. And then when I deploy it, for example, I can ask your address and give you permission to mint on the same contract. So then when it's deployed, I will get the address. I mean, I can actually either hard code it, or I can actually, as I'm doing it now, provide an interface so I can do it later on. Mm-hmm. So depending on what kind of scenario you want to do, I prefer to try and keep flexibility open, especially with these kinds of code, where you are able to add more people to it. So the first action is the action of defining the contract and also inheriting essentially all of the previous templates and libraries, right? So the previous libraries. And this takes place by saying contract topo token is ERC 721, ERC 721 burnable, pausable, and access control. I don't declare the counters as an inheritance on the contract, but I will use them later on. And then this one essentially sets up the cryptography for poser role and minter role. I will explain what KCAC 256 is, but essentially it creates a constant 32 bytes receiver address for the poser and the minter. So this sets up the contract. Then I'm ready essentially to, within the brackets, to write the code. And then I am then using counters for counter, right? And I set up token IDs private. So this is not accessible outside the contract. And it's essentially a counter that will increase every time I mint a new non-fungible token. Separately then from that, I have a constructor, which is public, right? So this is accessible outside the contract. And as I mentioned earlier, right, I can then create a default admin role, a poser, and a minter, right? Why would you have it differently, right? In terms of having different people have these roles? Well, it is good security practice that you allow other people to have control of the contract as well. You can only have only one admin, but it might be a crucial possibility that you allow the poser role, for example, to be an emergency role that is allowed for 2 or 3 other people other than you. And this allows you to immediately pose. The minter role, obviously, it's something that you would allow for any other kind of person that you would, any other kind of address that you would like to have access to minting. And then I proceed with setting up all of my functions for the contract, right? So function pause, public, I place a requirement, which is I need the caller of the function to have the poser role. And this is done by identifying the method center. So method center dot center is a functionality that Solidity has in the contracts where it identifies the center of a transaction. So this means pause the contract, but first of all, please check that the address sending the transaction actually has is in the poser list here, right? So connects this one with the setup or role here, and then activate the action. What is the action? Pause the contract. Always remember, if you put a pause function, you need an unpause function. Obviously, it might not be, well, for most people, they would kind of expect it would be the same button, but it's not. You need an unpause, and it's the same kind of deal here. The next function just unpauses the contract with the same functionality in terms of checking for the role. And then the much more simple function now, which deals with minting the non-fungible token, is the function mint NFT. I have address, the method center is the recipient of this mint. Please store in memory the token URI of the NFT. So this is the universal resource index for the token. And it should return to you an integer 256 bits. But first of all, I need to place some conditions, right? So first of all, require that the method sender has a minter role. If not, respond with caller is not a minter. And then I do a certain number of actions, right? So first of all is take the token's ID and increment and issue a new item ID, which is the token's ID current, which is the new number issued to the token's ID. And then a couple of two things: mint the new item, so the new NFT, and assign it to the recipient, which is the main address set up here, and then set up the token URI, which is connecting the new item ID with the token URI, and then return the new item ID to the recipient. So any questions on this particular code?
I think you explained it quite well, like it quite logical.
Yep.
I'm just curious, what if two people click on minting at the same time?
It's a classic question in blockchains. Well, it's never going to be one of them being at the same time. You need to say at the same time and closer to a node. So they need to be at the same distance on the internet to a node that will pick up their transaction and include it in a block. So one of them is going to be closer to one of the nodes that will include the transaction in a block. The more sure way to actually come first is not to use a third-party node and run your own. So we're going to see in the Python script that we're using a third-party service to talk to the blockchain, and that is using their node. If you want really fast transactions and to handle the transactions included in the block, best way to do that is run your own infrastructure, which, unless you are developing like us, I would not recommend that you go into doing it, because you will need to take one of your computers or hire a server online to do that. But that will be the answer to your question.
Mhm.
It's probably going to be impossible because one of them is going to be closer to a node, or they might actually run a node on their own on the local network. So one of the transactions is going to reach the blockchain faster than the other. That's always going to be the case.
I see. But then my follow-up question is, what if someone did a transaction earlier and someone later, and both reach the node at the same time?
I would declare ignorance of the blockchain protocol on that low level, but I will pick up your question and try to find an answer. So expect a LinkedIn post in the next day or two.
Thank you.
So I'm certain the protocol of Ethereum actually has an answer to that, but I need to actually check on what happens then. It would probably be a question of which node does your transaction get to first. So it will go again to the question of, because you won't be speaking to all of the nodes at the same time, you will again have a particular node you're talking to. And that then probably becomes a question of, is it one of the minting nodes, one of the mining nodes, or is it one of the relaying nodes? And that's where we're going to go into. But let me look into it, and then I will provide a more accurate answer. I don't want to provide an answer that is not really that accurate. So once you have your code, as before, what I did here, right? So we have, you need to set up a compiler, right? So here's an example of what will happen if I set a compiler at 0.6.12, which is lower than the one we need. And if I try to compile it, well, it will not allow me to do so. It will immediately jump to the latest version of 0.76. Try again. You see, it already corrects your mistake in that sense. So it will always compile with that. Let us try and do that. So compile the code. It gives me a little bit of a warning, but I will go ahead. If it doesn't give you any warning that is red color, then it has compiled successfully. So after compilation, well, actually, what it did is it compiled access control. Let me compile, actually, that was a tricky bit. I need to select. So what it did is it took all of the libraries, loaded them, and it didn't actually compile Topo token, but now we will do so. Okay, and then I'm ready. So it created two other pieces of code. One is the application binary interface. So I will copy this, and then I will open Atom so you can take a look. Sorry, my computer is complaining about my RGU account. So this is the Topo token code here. Let me open GitHub. So I prefer to use GitHub Desktop and Atom because they work out really nicely together. Let me do this commit from last week. I did something else on the other computer. Sorry, updating interfaces. And I will go here on the contracts, and I will create a new file and call it TPK ABI. You can give it any kind of ending you want. I'll just go with TXT. And essentially paste the ABI. So what is this exactly, right? So this is essentially the interface to the contract. So the compiler actually looks at all of the functions and all of the variables that you might have, all of the integers, strings, and so forth, and creates essentially an interface that you can use with libraries like web3.js or web3.py, right? So this is the interface these libraries are going to use to talk to the contract. And at the same time, it provides the code that the blockchain runs. So if I click on bytecode and I copy that and go back to Atom and say, create a new file. Oh, that's funny. Should actually be a little bit different. Let me try and see if. No, produce the same result. But essentially, the ABI is going to be taken by the compiler, and that's what the blockchain is going to run. So the next step is to actually deploy the contract. So we'll go here. I have already need to remember my password. That's not going to be easy.
We can see it.
Well, you can certainly not see my password. You see that I'm typing it, no?
Yeah. And encryption saved.
Yeah.
Yeah, it's always tricky to do live stream because what if you accidentally show some ID or key? So
Yeah. Come on.
Now we can definitely see it.
you're Richa, you are adding.
No. Let me try. Sorry. I'll just stop sharing to be prudent. In classic fashion, I have it was a moment of English, UK English versus US English. So it is sensitive even with that. So okay. So so you see my account ArcChain1. You see I'm really poor. I have no ETH on this one, but this is only because this is on the really live network of Ethereum. If I change to Ringby, you should see I'm rich. I have 3.7 Ethereum, so I can actually deploy a contract on this network. So always remember, it's the same address that you're using in the test network and in the real network, right? It doesn't change from our point of view. I think Robson, I had some as well. Coven, yeah, a little bit, but we'll go with Rinkaby.
And so in order to get this address, one should create ArcChain account, right?
No. You don't need to create. I just named this ArcChain1 so that I remember that this account is the one I'm using for ArcChain deployments. If you need to create a new account, you just go here and say create account.
Okay, so it's your personal account key, not a particular contract you created.
Yeah, exactly. So this is just a personal account which I use for demos and also to test our research, right? So with Vasim, we have and David, we have ArcChain1, ArcChain2, ArcChain3, and we kind of use these accounts for when we change something on Topologic and we send it, we use these accounts to be able to track because it became cumbersome to use our personal accounts. So you can create as many as you want, right? It's just a matter of actually remembering to hold on to the password and not forgetting them. So you'll see ArcChain2, right? These are connected. Yeah, and as I was saying, right, so you have all of the test networks, and you just need to remember where you have funds from that point of view. So as I have that, you'll see I change here. If I change here from JavaScript, which is the normal function for Remix, I change to injected Web3. Have I connected the account? Yes, I have. Should pick it up. So this is the way I would do it with if I had a node on my computer, I would go with Web3 provider. Injected Web3 can detect network. Okay, there's something going on. Connection is open, provider. Yeah, so even though I have MetaMask connected here, it doesn't recognize it. So what I will do is copy everything, even though I have it on and reload. Same code, so it saves your local environment unless you clear your compile it again, and just go here, and here's a change now. Ethereum is about to be upgraded to the London version. So you see now it provides Berlin and London. That's why it didn't allow me to connect. It wanted me to reload so that it reloads with a new interface. So the moment I go in Data Web 3 and I have my account connected, you will see that it picked it up, right? So this is the account I have on MetaMask, right? So I usually check the last digits, 923E, 923E here. And now if I go deploy, I will make a mistake because the one loaded is the access control from OpenZeppelin. I need to click here and go to my contract, which is the last one, right? So all of these are the libraries I have loaded onto my code from OpenZeppelin. So I go here and go deploy. I get a transaction started. I confirm it. And I get creation of topo token pending. And I get confirmation of the transaction. If I click on it and then view on SSCAN, sorry, just take it here. First of all, it will tell you that this is a Rincon-B testnet transaction, right? So it's not a mainnet. Try again to reload, and it gives you all of the information you want to know whether it was successful. If you get a success, then it means it's deployed. You get the block and how many block confirmations have passed. So that increases as many blocks as you have mined since, that increases your confidence that the transaction has passed. And this is my account. And now this is the new contract that is created just specifically for this contract, right? So this is the address on the network. So I will copy this and I will go back and change this and say this one is located here, but also I will change the network because it's deployed on Rincon-B. Okay. And now here you will see that the interface I have is much more rich compared to the very simple contract I set up. Why? Because I'm using the OpenZeppelin libraries. So let's do this, right? One of the things I can do is create a new role for ArcChain 2. So I will copy this address place it here, and I will grant ArcChain2 account the possibility that, okay, it's waiting, argument value, it's not proceeding, probably because I have forgotten what to put in the, oh, sorry. Nope. I wrote it. I'll find what I have forgotten what I need to put here, but essentially this is the mechanism with which you grant a role to someone from the contract. But let's go to the non-fungible token part, which is the exciting part. So, Mario, do you have an address that you would like to use? So I can give you the first token.
Like address in the sense web page or like
No, an Ethereum address. So that's the only way this will work. But never
I
mind
have
if you don't.
MetaMask account. I don't know.
So if you go to MetaMask, so do this. If you go to MetaMask and you create a new account, and then for that new account, give me the address on the chat, and then we'll use that to give you a token.
Yeah. So address by this, right?
Yeah, like this one.
Yeah, I shared in the chat. Yeah, yep.
Give me a second. Yeah, perfect. So I will place this here, right? Recipient is this one, and instead of giving a token URI, which would be a string on IPFS or similar, the way we were, you'll see it when it works with Web3, we would normally provide to token URI a topologic string that recreates essentially vertices, edges, faces, essentially. So that was our kind of smart way of creating tokens that represent specific parts of the topology of the building.
Oh.
Or what we do is we pick up the whole topology, hash it in IPFS, so upload it to IPFS, and we'll say the whole topology of the building is this particular token, and that acts as an identifier of the building. But let's have some fun here. Let's write messing with topology and blockchain is fun. Because essentially at the low level, right, this is just a string. You can write anything to it, right? You can say, Mario Messi is fantastic, right? So you can, so let's transact with this. And we get a gas estimation failed, which basically means that the transaction is likely to fail because we haven't put in a lot of for sending, but also I've made a mistake because the connection I have now is with ArcChain2, and I haven't given ArcChain2 a mint role. So, and it's mentioned here, execution reverted caller is not a mint. So I will cancel, go back, change to ArcChain1. And transact again. And you will notice that I will get the interface of MetaMask. And immediately I get transact to Topo token, and then you will see it mentions the function mint NFT. So it gives me the contract and what particular function I have. Okay, transaction confirmed. And here it is on the SSCAN, so I can actually navigate and see what the case is. Click more, right? And it will give me essentially the address of the recipient and the string token URI. And here you go, here's the message we wrote on the blockchain, right? And if this was a topologic function, right, we would be able essentially to read from the blockchain the configuration of a specific topology and reclaim it, recall it on our desktop. And we'll see how that takes place by using Python. An easier way to see what we've written is if you go back to the interface here and you scroll down and you get, please let me know who is the owner of token ID 1. And you will notice it will give me, and that's your address, Mayer.
Nice.
One way to actually see that you have this this token is if you install MetaMask on your mobile phone and you connect it to Rinkeby, and then I will give you the address of the contract and you'll be able to verify it on your mobile phone. But same as well, if you try your account on Rinkeby ffscan.io, you should be able to see that you have that first token. Unfortunately, it doesn't have a lot of value, but at least it's a first start.
Yeah, I have like 2 questions. So,
please.
In my mind, I was assuming the test network was locally, but it looks like test network is also on the like on the cloud or on the server.
Yes. No, it's a full blockchain that doesn't have any value. So it's run by the blockchain developers, by Ethereum developers. They maintain this and they do all of their tests of developing before they try something on the mainnet. They try it first on this. I like to use, so you can run your own blockchain on your desktop machine, but I prefer to actually do all of my tests with the test networks because it's a closer environment to the real blockchain you will have. Sometimes it is slightly annoying in the sense that you have to load an account, pay gas for it, and it might not be as fast. So depending on what kind of scenario you have in terms of what you want to do. So if you're learning, I think running a blockchain through Ganas, as I showed last time, is the fastest we learn. If you are actually closer to deploying something that you want to test under real life conditions, then please use the test network. You can do that also through Truffle, and that gives you a better experience and let's say more rigorous kind of testing compared to one you run on your own machine.
And that's why it's making sense, because you need to have some amount of money to pay to get storage and space on the. Okay.
Exactly. So what was the second question?
Oh, I forgot. Okay,
that's okay. If you remember,
yeah.
So you can ask. So all of these. So when you get the Remix interface, the orange buttons, they are all triggering some kind of function on the smart contract. So it will actually actively change the state of the contract, whereas the blue buttons actually are reading from the contract. So orange is writing and blue is reading, this kind of CL kind of color is reading. So you can try, for example, sorry, you see my address here. Let's put your address and say call this one. No, I need to give it your index. And it's out of bounds. Let's see why. So you see, this is the kind of console that you get. Yes, execution reverted, and you will set index out of bounds. So what happens when you try to talk to a blockchain and the transaction you send forward is not well constructed? Essentially, what the node is going to do is going to revert it back and not change anything on the contract. And at the moment, it seems that I'm not sending anything, right? So this is stopped before I even try it. Which probably means that I haven't set this setup correctly. So give me a second to token by index call this one, or go index 0 actually. Yes, that was my mistake, right? So the index of the first token you do is not 1, is 0. Yeah, classic mistake. Classic programming mistake, I would say. Even though when I do it here, it also does the same. Okay, I'll have to find out what that is again. But I can also ask how many tokens I've minted, right? So this is 1. And then I can ask, what did I write on what is the token URI of token ID 1? Sorry. And then it will say messing with topology in blockchain is fun. So you see the string is already there. So when you deploy, you can immediately use Remix as a testing tool before you actually try connecting with any kind of desktop, right? Okay.
So when people say they mint an NFT with image or videos, right now we see string, but where's the?
So what they do is they don't. It will be very expensive to actually store the whole video on the blockchain. So what they do is they use IPFS. They store the video on IPFS, take a hash, and then put that in here. So this is what I'm going to show now. Essentially, I'm going to try something in Blender. I'm going to model a really simple topology, upload this to IPFS. I don't think I have it here actually. Let me. Oh, I have it. Okay, perfect. So I'll open it.
Or and the reason is because string is way more efficient and to store it on the blockchain rather than the whole. Okay.
Exactly, rather than storing the whole file essentially. And normally this URI, this universal resource locator, it could point to a centralized server. So you might have, sorry, my second computer goes out. You might have essentially some of the NFT marketplaces, they have that kind of problem. Because what happens is they store the media on a normal web server. Now, if that web server goes offline because the company goes out of funds or defaults or what, right, or there is, it gets destroyed, you will lose that NFT. So you will still have, you will still have ownership of the NFT, but you will lose the media. So always pay attention that, it wants to update. Okay. Please restart. Let me redo that again. So when you are buying an NFT from a marketplace, make sure that both that the blockchain is using, first of all, is legitimate and decentralized, but also the storage of the media that they're using is also decentralized. Because a lot of times I've seen people, there were a lot of new marketplaces created that were using web servers, and that's really bad practice in a sense. So I am connected now to IPFS. I don't think I have, so you see I have another 203 peers around me. I have a hash that tells me this is my ID. I have no files yet here, so I will switch to Blender. And let's try and model something up. Okay, I think I made it complicated enough. Let's save the file. Might get lost in my own computer. Let's go here. Basic topology. So save it as a blend file. But then to share it on IPFS, I'll do the same thing. Find the file and upload it here. So now it's on IPFS, and some of my peers will start essentially hosting the files themselves. And that's what makes it resilient, is that it's not only on my computer, but it's all on IPFS peers all around the world. And it can be retrieved just by copying the CID here. So
So
I
it
will
will be
go back to
downloaded
my,
on all of your peers, like the
yes,
whole file.
yes.
Oh, so if it's in GB, it's gonna.
Yeah, so if it's massive gigabytes of data, right, you will have trouble from that point of view. So, but there are services that are built on top. So IPFS is essentially a low-level protocol. There are services like Filecoin or Piñata that allow you to pin a file and essentially pay the nodes that will host this. So if it's a large file, because essentially IPFS peers will certainly host the files of the owner. So as long as I leave this here, right, it will say it there. But I cannot guarantee that all of my peers will copy it, essentially, because if it was a, say, 2 GB file, right, I need to incentivize them. And that's where, again, the blockchain comes in, right, and you can use essentially Filecoin to pay them to host it.
Yeah. Sorry, I just realized
that kind of creates.
you have to leave, so I won't ask any more questions. We can finish the demo first.
Yeah, that's fine. No, that's fine. I keep on forgetting as well. So if I copy the hash file and I go to here, and I sorry, where am I? Here, and I paste it here. I still will leave your address on, and I transact. So I'm minting now that Blender file for you. So it's minting, right? So if I had a topology on this, it would essentially describe the building, and then you will be able to retrieve it, right? And as it will happen, right? Take it as an exercise left to the reader, right? You can actually look at the CID of the token, and you can download the file from IPFS. I will leave this running. So if I go here, it will tell me here's a transaction. It's still indexing. So logs data and a UDF input, and anything starts with Q, that's now your file. So that essentially locks that particular building on this particular NFT. And if I go and ask, tell me the address that is the owner of the second NFT, it will give you the same address. But if I ask, tell me what the second NFT contains, I will get essentially the CID, right? Now, the trick of what we're working on now with Vasim is that we are picking up from the topology, we are picking up building components, and we're minting a series of NFTs. And then these are all created with a master NFT. So that's the next level we're working on at the moment using this particular contract. But so far we've shown half the paper you kind of was reading essentially on that level. Now, how do we take all this and use it? Because so far I've been doing everything manually, right? What I can do is I can go essentially onto Dynamo. Come on, right? And the trick here is you need to download Anaconda and set up a Python environment. And after you set up that Python environment, you need to essentially use it here. Go and set up CPython 3, and you'll see how in the Python file I also use it. Sorry, where did it go out? Oh, I'm completely hopeless with sorry, it's still up with Dynamo. So this appears really complicated, but let me explain again what happens with this particular Python code. Maybe I copy all of it. Sorry. Because this will give me the possibility probably to zoom in. So our viewers will not go blind like I do. Okay. Sorry, let me close the rest of the files. Oh. And then let's navigate now how we set this up. So to be able to talk to the contract, you will need to install Anaconda, set up a Python environment, probably with Python 3.7 or 3.8, and then do a pip install Web3. And this will install Web3 on your computer. And you will see now what I will try and do this. So you need to declare the contract address you are talking to. And this was this one I had. But note that I deployed this to a new one. So I need to go here, copy the value from the contract I have here or from where I deployed it there, and paste it here. Right? And I also note normally which account it belongs to, so I don't get confused with who is actually accessing it. The wallet address is ArcChain1, right? Address is the same. I could actually delete that. Wallet private key, be careful, never do this, right? So never do what I did here, which is give to the script my personal, well, it's not a problem if I give to the script my personal key. The problem is I'm publicly giving you my key as well. That's why now ArcChain1 is completely useless to me for a real transaction, because anybody watching this video could steal my funds, right? So, but in any case, one way to deal with this is if you save a text file with your credentials, your wallet address and your wallet private key, you can then on Dynamo create essentially a text file that will go into another one of those inputs here. But back to the code, then I use in Fura URL, you need to say to the code, the Python script, which node you're using. So either it's going to be a blockchain node that you have on your network, your own personal node that you're running, which probably you don't have. So better you use Infura. So Infura is a service by consensus. It's free for the first 10,000 calls. So I don't think if you're testing something, you're not going to read anything on the paid tier. Just go there, create an account. So this is what it looks like, right? So this is our decentralized BIM node. And then if you need to use the same endpoint as the network you're testing on. So you see there are Robson and so on. So Rinkeby, and then I copy essentially this address here. Conversely, if you don't want to set up your own, you can use mine. It's because it's public, it won't be an issue. And then as we go down, right, this is now the path. This is now the crucial bit. This is the path with my Anaconda environment. And this is where the Python script from Dynamo is going to go, well, where do I find the Web3 location, right? This is where it is. I change depending on whether I'm using, so because we're using the same script on Blender and Linux, you might change it for Linux from a point of view. And then you remember the contract ABI, right? Here it is. But you need to do two things, which is you will notice the contract ABI is like that, and the contract ABI I have here is one line. So what you need to do is go copy this, and because the contract ABI is in a JSON format, search for an online converter, convert JSON to string. Well, it gives us direction. No, convert JSON to one line probably will get me what I want. Yes. So it's a multi-line to single line converter. Paste the ABI here, go convert, copy it. And here's the tricky bit, which took us a lot of time to figure out. If I just paste this on Python, it will complain because on Dynamo, it requires that I insert a backward slash before the double quote. So we go, sorry, before the, the double quote. Is it not? So you need to essentially replace double quote with backward slash double quote. And then copy and paste this one. But I have it already. And then import time, import this from Python. From Web3, import Web3, right? And SAP provider, this is telling the script, yes, this is the node I want you to use that I set up above. And then the string here, and this is where the magic happens, right? So you'll see this one is a topologic command. So that's how we do it, essentially. We feed in the topologic command into the strings, and this is how it then writes the blockchain. So if I copy this and go from hello, Major, it is nice to meet you, to give it this, sorry. And then I use essentially, it took us a little bit of time to learn, and this is where the Web3 read the documents documentation is really useful in the sense that it gives you examples of how to set up then all of the Python code. Because up until now, what we're doing is we're just basically building infrastructure, saying, here's the node, here's the contract you need to talk to, use this account, and here's the message I want you to send, right? Now, the what you need to look at making transactions, right? So how do you send them, how do you package them, and so on and so forth. You'll see some tests like in using the inferior InconB node. So going back to the Python script here, I'll give you the overview. You're declaring essentially which is the smart contract you want to use, and so this is the address, this is the ABI, right? So you're saying to Python, here's the interface, here's the contract, and here's the interface. You're asking for a receipt of the transaction. You might not want to do that, but it's good practice so you understand, what's going on. And then the important bit is here. You remember the numbers used only once, right? So you need to go back and read from your wallet address like that. So this is the nonce you need to build. So read from my wallet address, what is the current number used only once? And then build the transaction. So this builds a transaction that is going to be sent as a packet to the blockchain, right? So on a low level, this is what a transaction looks like. And it says, I want you to go to the smart contract, look at the ABI, and call this function, which is minting the NFT. Give it the address and the string, which is going to go to the token URI, and build a transaction. Chain ID is 4. This is the number ID for InconB. This is the gas I want you to use. Some of this was throwing errors, so double check the gas amounts, right? So you might want to add a 0 here or more, and play with the gas price, right? Again, if you're still testing, it's not a big problem, but in a real blockchain, you will need to optimize this so you don't pay more, right? And then the number used only once is the one from the web wallet address there. And then everything else is sign the transaction with your personal key, with your private key, which is the part that uses cryptography and verifies you. Create the hash, which is going to send it, right? And everything else then is a number of receipts that we want to receive from the blockchain back saying, tell me the block, tell me the gas used, and anything else you might want to know from our point of view. And print it, right? So what I'll do is, I had it ready here. I'll go back to Dynamo. And I'll pick up my copy CID, and through Dynamo, I'll paste it here and save and run it. So it says warnings. So I have a problem at string 214. Okay, interesting. Okay. I pasted this before and it throwed errors. Save it again, run it. Yeah, I think I've, with all of the copy pasting, I have messed about.
I think the string got changed. You wrote something else
Yeah.
there.
I think what I need to do is go back here. Yeah, this has changed. So this was a case of me. Let me see if I have a clean, no. Okay, this is correct. This is correct. So I'll change the string. I'll give it a topologic vertex. Same problem.
Yeah. I think like we got an idea of the whole
Yeah.
workflow. So I know we
No,
are running tight on time, so it's fine.
yeah. I think what I have made a mistake with is the ABI. So by copying the ABI, I did it really fast. So the ABI, it's really sensitive to what ABI you're using. Probably I'm using an older version. So I would, this is where you need to actually go and really carefully copy paste and actually make sure you're providing the same ABI for the contract you're using. But it works. I mean, if you try it, you will be able to then do the same thing from this kind of idea. But I really need probably to kind of set up a video that shows all of the steps, and probably it's going to take a little bit longer. Same for how to do it from Blender, because normally in Blender with Vasim we use Linux. So, but that's the main idea. And then anything you feed into that string will basically become an NFT. And one way to do it is either use again Python to talk to IPFS and upload the file, or just use topologic to analyze everything and then represent it as an abstract version.
Yeah, and I must say that I have seen a lot of tutorials, and watching this step by step, like I feel more confident. Okay, how the network
Yeah.
is working, and like you explained it amazingly well. So I know you want to leave, but I have three quick rapid fire question which I want to ask, and you can. So we looked at the smart contract, and in your first presentation you mentioned about Turing complete. So I am not sure if we saw like the smartness of the contract right now. Like we saw like how we gave different roles and pausing. Like there are some auto completion commands, so we add those functions in the soul file.
I'm not sure I understand exactly the nature of the question. So in terms of Turing complete, the Turing completeness has to do with we do not know whether the smart contract will go into an infinite loop. To stop that from happening and wasting resources on the network, we introduce the concept of gas, and that's how you pay for gas. So when you send a transaction and the blockchain responds back saying you run out of gas, two things are happening. You haven't optimized your code, or you have one function that is not well formed and goes into an infinite loop. So you run out of money essentially to run that particular transaction. In terms of the idea of the smart contracts, it is that they are always there and they're always reliable. So now by deploying this, that contract will always remain there. And it will continue working as long as the block, unless you go and you physically destroy all of the blockchain nodes that exist, that contract will always remain there. And it will always behave in the same manner. So if you go and trigger it in the same kind of way, you will get the same kind of result, right? So that's the equivalent of a vending machine. If you put in the coin, by you will get a behavior. Now, the code we have for developing a circular economy with this is much more complicated. So it involves 2 or 3 more contracts, which would make, like, I mean, as I said, right, I'm trying to get a workshop in Icadi, and if I do that, then I'll have like 2 days to showcase this. So the main idea here is that the contracts are always there. They're always dependable. You don't need to rewrite them or redeploy them. And the smartness of it is that they worked as an automaton, essentially.
I see. Okay, yeah. Okay. I was a bit confused when, like, the autonomy of smart contract. I thought we code a function where, like, if people are uploading their design, it automatically reevaluates, or like some decision making.
Yes.
Yeah.
So you can do that if you use 2 or 3 contracts. So one contract would actually gather the values, and then you might have an evaluator that basically looks at the values and compares them with either a predefined value, or you might need a machine learning algorithm making decisions, touching them to the third smart contract and saying, well, that value is optimized or is not optimized. So the tricky bit is that the smart contract doesn't contain actually any kind of judgment. If you want any kind of judgment, this will have to be either a human or a machine learning algorithm that will provide you an answer. But once you provide that answer, you're guaranteed that the smart contract is going to execute according to the rules you've set.
Oh, that really clarifies a lot of things. And next quick question is, like, for if I'm minting different components of a building, I'll have like different strings on IPFS. So, like, does the end user who would be downloading all this file will be compiling all the components locally in there?
No. So the tricky, the creative cheating the way with topologic is this: you create the whole topology, and that topology is then being uploaded to IPFS, and you get the CID, which is minted. That is kind of acting like the master file of all of the components. And then each one of the topology strings that describe the topology, so the vertices, the edges, and so on, these are then minted as unique token URIs. So you only need the master topology as a user to find out, okay, this building contains, say, 16 concrete columns and 24 concrete slabs. And we're now building the user space tools where you can go, okay, please find me column number 4.2, right, and retrieve it and give it to me in the software. And this is how the circular economy is going to work, right? So you will have essentially a registry of all of the existing or of all new buildings being designed with this tool. And when you need to recycle them 20 years later, that registry is guaranteed to be there.
Awesome. Okay. Final, like, is there any way we can access these files on GitHub or other?
Yes. So if you go to the BIM and blockchain, what I will do is I will let me make certain that I only have it on my test repository, but
I can add it to the video description later. So
I will give it to you here. No, that's come on. Sorry. I'm normally using a Mac, and I'm used to copying pasting between machines. So when I switch to Windows, it's so our test repository where everything breaks and everything is being made is here. And what I will do is I will give you this one on the chat. but also I'll make sure I provide a public. So this is public already. You can take a look, but it might be confusing on which version is the latest. In the next month or so, we'll have one on the BIM and blockchain repository. So if you want to give it to your viewers, the examples, let me see, I have it here. Yes, it's here. So all of the decentralized BIM work that we do, I would suggest you use this one, because that is guaranteed. Everything works and it's much more clean. And it will, it will be updated with, when we finish with the tests, we will transfer it to this one.
Awesome. I would like to conclude by saying, like, it has been a great workshop. Like, we saw the theory, implementation, and I hope a lot of viewers now will be more interested and get familiar with AI for blockchain for AEC applications.
Mm-hmm.
And I really want to thank you for all of your time and effort to do this. It has been an inspiration to see your work and discuss with you.
Thank you so much. And if any of the viewers or readers have any questions, feel free to contact us and ask questions, and we're happy to help. And looking forward to seeing you again in one of our workshops.
Definitely.
Thank you again. Bye-bye.
Thank you, Theo. Bye.
Bye, Theo. Thanks for the lecture. Okay, you already left.
Yeah. Cool. Thank you guys for attending.
Okay, bye.